Hey everybody, it's good to be back. Welcome to Galactic Wisdom. Now today on this show, I would like to talk about where we come from, how the universe got here, how old is the universe, where the Earth came from, how we came to be here today. Um, Now I'm a space scientist. I'm a space scientist. I'm a space technologist. I have a first-class honors degree in physics with space science and technology. So I understand the value of knowledge, of trying to figure stuff out in a way that you can know something instead of believe something. And this is a theme that I've talked about quite a lot on my show. That's the difference between belief and knowledge. Um, One of the things that is holding us back as a species is that we still believe stuff. Now, belief and knowledge are very different things. Belief is accepting something as being true without proof. Knowledge is accepting something as being true because we have proof. Those are two very different things. Oh, I even have a graphic on about it here. If you don't have proof of some, well, how about that? My door just opened behind me. Okay, I'm just gonna welcome whoever just walked into my room here. Um, they obviously want to listen to what I have to say here. That's fantastic. Um, if you don't have proof of something and you accept the thing as being true, that is intellectually invalid. That's what beliefs are. Now, it's very hard to say to everybody out there, stop believing, because believing and beliefs are such a big part of our world and have been for the entire history of humanity. But we need to do better than that. A few hundred years ago, logic really took off. Logic being the process of making deductions that have to be true, that can't not be true. We started using logic in a way that we were making deductions that are correct about reality. And we started to have an expansion of knowledge that we call science. Science is based on using logic to determine what is real and what isn't. And this is new in human history, that we have this ability, this understanding now that we can use logic to work out the truth about things, the truth about reality. And that's what science is. And science has accelerated rapidly in the last 300 years to the point where, well, I can use a microphone, which is science-based, talk into a camera, which is science-based, and use a computer, which is science-based. And you're probably watching me on computers and other devices, which are all science-based. We can make these things. We have these technologies because scientists use logic to understand reality sufficiently well that we can make these things and communicate in this way. I'm going to use the same principles of knowledge, of using logic to acquire knowledge, to talk to you today about where we came from. I know that some of the things that I'm going to say are inconsistent with belief, but I'm going to be blunt. Beliefs are invalid. Accepting things as being true, 100% true, without proof, that's intellectually invalid. We're going to have to drop beliefs as we evolve into the future. If we think of ourselves 1,000 years from now, nobody's going to believe stuff. We're going to know stuff. If we look at our alien friends that are out there, who are supremely advanced scientists, they know stuff. They don't need to rely on beliefs anymore. So I'm going to focus today on what has been proved about where we came from. Now, the subject of space and where we came from in space, that's called cosmology. I used to do X-ray astronomy or astrophysics, and that was all connected with the subject of cosmology. And I'm going to state things here that to some people are going to be against their beliefs. But I'm going to ask people, please, to consider that what I'm saying might be true, because it is true. The things that I'm going to say are as true as this being a mug, a green mug that says Area 51. People, if you want to become enlightened and ascend, there needs to be a few paradigm shifts, a few paradigm changes, a few waking up moments, and moving towards knowledge instead of belief is one of those changes that is required for us not only to evolve and to ascend, but also to save our planet from a number of very catastrophic events that are approaching us quickly. So how old is the universe? Well, that's an interesting question. Scientists will tell you that the universe is understood today as knowledge to be approximately 13.77 billion years old. So that's about 13,800 million years old. That's very old. That's the age of the universe. Now, that's the age of the universe at this point in time. My paranormal knowledge tells me that time is not just one-dimensional, that you can travel through time. Spirits and spiritual information travel through time all the time. We can astrally project through time. And so time is two-dimensional, because when you get to another time, you can affect that time. And in order to change the timeline to affect time, you need a second dimension of time to affect it. Otherwise, you end up with paradoxes that are impossibilities. So at this point in temporal time, the universe is 13.77 billion years old. But if we were to travel, let's say spiritually or in some kind of alien UFO, if we were to travel, let's say 1 billion years into the future, which we could do now, then at that point in temporal time, the universe is 14.77 billion years old. Now, what would be interesting, an interesting experiment, is to try and remote view or astrally project into the future and see how far into the future can you go. Because when you get to that point, when you can no longer keep going into the future in temporal time, then that will tell you the true real time of the universe, which is obviously at different points in the timeline, different from the age of the universe right here, right now. But at this point in time, we are 13.77 billion years on from the Big Bang. Now, a lot of people who look at science news, you know, it's very hard to find proper science news certainly in the US. All of the news stations, news networks, you know, a lot of them are not news networks. A lot of them are misinformation networks. When you look at how they frame science news, it's all clickbait. It's all telling you things in a way that is very misleading. Like scientists are shocked at this revelation that changes everything. No, they're not shocked. They just discovered one more little piece of news that they'd theorized about for 100 years anyway. News in this country is not very easy to come by. So it is hard to find real information about this that is out there. But I worked in the field, so let me tell you some real information. Good scientists know that there's a lot about the universe that we don't know. We don't know what dark energy is. We don't know what dark matter is. We don't know why the universe doesn't have equal amounts of matter and antimatter, which theoretically it should have. There's some big mysteries out there. But We understand the confines, the limitations, the scope of those big mysteries. And when scientists say that the universe is about 13.77 billion years old, they're approximately right. They have worked out things that we can know to be true. When scientists do any calculations, they use something called a margin of error. Now, a margin of error is not that some people think it means that the humans are fallible, and therefore we need to understand that there's an error, a possibility of error. No, it's not like that. It's like each piece of equipment you use. It's only sensitive to a certain amount, and then beyond that, there may be little bits of error associated with that. And so you build in all of these margins of error. And this 13.77 billion years old, sure, there's a margin of error in that. But when a regular person in the street hears, oh, there's a margin of error, they look at that and say, well, it's not true then. There's an error associated with it. It must not be true. But that's not what margin of error is talking about. We can know through actual acquisition of factual evidence that the universe started approximately about 13.77 billion years ago with a big bang. And, we don't know all of the details associated with that, but it is not a theory that there was a big bang. This is knowledge. And I'm saying that with confidence, and I'm going to tell you why I'm confident to say that the universe started with a big bang, because I can explain it to you right now. When we look at the moon, we see how it was about 1.3 seconds ago, because it takes light a certain amount of time to reflect off that moon, sunlight reflecting off the moon, and it travels a huge distance through space into our eyes, and then we see it. That travel time takes about 1.3 seconds. So when we look at the moon, we see how the moon was about 1.3 seconds ago. When we look at the sun, that's even further away. That's 150 million kilometers away from us. It takes light over 8 minutes, about 8.3 minutes, for the light from the sun to traverse that distance to the earth. And so when we look up at the sun, or when we look outside and we see anything reflecting sunlight, that light left the sun about 8.3 minutes ago. And when we look at the sun, we're seeing how it looked over 8 minutes ago. If we go outside and look at the sun, that's not how the sun presently looks. That's how it looked over 8 minutes ago. That sun might have just been eaten by a giant mutant space donkey, and you would not know for another 8 minutes. When we look at the nearest star to us, the nearest star to us is Proxima Centauri. It takes the light from that star 4.3 years to travel through the vast depths of space, that vast distance through space to get to us. So when we look at the nearest star, we see how it looked 4.3 years ago, not how it presently looked. It's 4.3 light years away from us. A light year is the distance that light travels in a year. It is 4.3 light years away. When we go outside and we look at Orion's belt, which is one of my favorite places to look at, because a lot of the beings that I communicate with seem to have origins, or at least associations, with that region of space. It takes light 800 years, 900 years, and 1,300 years for the light from those stars to get to us. Orion's belt is approximately 1,000 light years away from us. So when we look at Orion's belt, we're seeing how it looked 1,000 years ago, not how it looks right now. Our galaxy, it takes light 100,000 years for light to travel all the way across the galaxy. So when we stand at one one side of the galaxy, if we were to stand at one side of the galaxy and be able to see the other side of the galaxy, or stars from the other side of the galaxy, um, it would take 100,000 years for light to traverse that distance. And when we do see the Milky Way, the furthest part of the Milky Way from us, we're seeing how it looked 100,000 years ago. Some of us might know that when you look up into space, you can see a galaxy called the Andromeda Galaxy. That galaxy is presently about 2.5 million light years away from us. It appears like a little smudge of light in the sky. And that means when we see that, we're seeing how it looked 2.5 million years ago. That's before human beings even existed. Incidentally, that galaxy is hurtling towards us at a rapid rate. And one day in our future, we are going to collide with the Andromeda Galaxy. That'll be fun. I wonder what will happen then. In fact, I wrote a book about that one time. So I'm going to continue my train of thought here. Keep going further and further away from us, further and further looking back in time. And I see that I have a few comments from some of our audience, so I'm going to get to those comments after I've finished this little section here. We can keep looking all the way back to, well, here's a photograph that the Hubble Space Telescope took probably about 20 years ago. That's the Hubble Deep Field image. And the light from that image has traveled to get to the Hubble Space Telescope. It traveled approximately 13 billion years. So that photograph is a photograph of how one bit of our universe looked 13 billion years ago. And all of those interesting bits of light that are in there, I'm not sure they're all specks of light, smudges of light, all of those different bits of light in there, each of those is a galaxy, a whole galaxy like our Milky Way. And Hubble has been not replaced, but another space telescope, as you're probably aware, the James Webb Space Telescope was launched not that long ago, and also did a deep field shot. And this is the James Webb Telescope's deep field shot, and that also shows galaxies about the same age, approaching 13 billion years old. And if you zoom in on part of that image, what we see on the right-hand side is a little red spot, a little red star. You know, I'm moving my mouse cursor onto it as though you can see my mouse cursor. I know you can't, but it's towards the upper right smudge of red light. There is a little red light, which is a star called Earendel. That's what we've named it. And that is the most distant star that we have been able to image and identify so far. And that is approximately 12.9 billion years old. The light from that star left 12.9 billion years ago, traveling untouched through the universe for 12.9 billion years until it hit the sensors at the back of the James Webb Telescope and ended the life of that light. And that's pretty remarkable. So the point I'm trying to make is we can look further and further back in time, and we can use proper scientific knowledge to figure out just how far back in time we're looking. And there is something really cool that we have been able to image, because when you look back far enough, this is what you see. And this is false color because it's not visible light. Any visible light that left at this time, which was 13.4 billion years ago, has been drawn out. The energy has, the wavelengths of the light have been stretched out to wavelengths that are so long that our eyes can no longer perceive them. So this is false color. This is a microwave image of microwave radiation that's been traveling through space for 13.4 billion years. And we know what that is. And you might not be able to tell just by looking at it unless you're an astrophysicist, but that is the afterglow of the Big Bang. Let's assume there was this big fiery mass of energy, and that just somehow, and I don't know how, I don't think scientists know how it happened, but let's assume there was this big fiery explosion called the Big Bang. Everything was crammed in really tight, close together, including all of the energy, including all of the light, including all of the matter. And if you could have put a camera right in there or stuck your head in there to take a look, you wouldn't be able to see anything, because it's just like a soup of energy. Obviously, you're sort of burn very quickly. But if you could have this super resilient camera, you wouldn't be able to see anything. It would just be white. Any light that's trying to move through that soup would just immediately hit something else and wouldn't propagate. But then this ball of fire expanded outwards, rapidly, outwards, and something like 900 million years after expanding, it was a pretty long time, then the photons of light were far enough apart from each other that you started to get bits of empty space between them. And then, for the first time, the universe changed from being opaque to transparent. Light that started flying off of something hot could travel through space. And as the universe expanded, more and more of this light could propagate from the early universe, from that moment when the universe started to become transparent. And light has been traveling from that moment, since, through the universe. And when we look at this image is of that light. This image is of the fiery universe at the moment when it had cooled down enough that this light could then propagate through the universe. We're looking at a photograph of the Big Bang. When people say that the Big Bang is just a theory, even when you go online and you see that through political correctness and because of everybody's religious beliefs out there, they have to do this. When you see them saying that the Big Bang is just a theory, no, it's not. We certainly don't know all the details of the Big Bang, but we know that it's real because we can see it. We can see it in space. Also, when we look into space and we see all of these galaxies out there, and we start, scientists are clever. We can look at that light, we can analyze the light, and we can determine, due to something called the redshift, like it's a Doppler shift of the light waves, we can determine how fast those stars, those galaxies are moving and in which direction. And one of the big cosmological discoveries was when it was discovered that when we look into space and we look at all of these galaxies, there is an overall pattern of these galaxies expanding away from each other, flying away from each other. And we see the same in every direction that we look. All of the galaxies flying away from each other, and the further away you look, the faster they're flying away. That can only be explained from them having started off closer together. And if you just use your telescopes and look back in time, and basically it's like running a video backwards, you see all of the galaxies coming together like this to the Big Bang. Galaxies, all matter in the universe, all energy in the universe started with a Big Bang, and now it's expanding outwards. That's been proven. It's been proved in a number of different ways. So if you have different beliefs, please understand this. Please understand that, people used to believe the earth was flat. They were wrong. And it's easy for us to look back at those people who believed that, and believed that the earth was the center of the universe and the sun orbited around the earth. It's easy for us to look back at them and know that they were wrong. In a couple of 100 years from now, even right now, most people can look at the people who have beliefs contrary to the Big Bang, can see that they're wrong. And when you don't have proof of something, when the only evidence that you consider to be proof is not actually logical proof, it's just something that has been told to you, maybe written down somewhere once upon a time, that's not logical proof. And we need to move away from that sort of belief, from every sort of belief. Beliefs are intellectually invalid. They don't just open ourselves up to making mistakes, they are mistakes. In the same way that saying 2 plus 2 is 29.5, having a belief is incorrect. So that doesn't mean to say that we can know everything in the universe. I certainly don't. Scientists certainly don't. But what we can do is we can know what we know, and we can know what we don't know. Knowledge is so much better, so much wiser than belief. So that's how our universe started. Let's move on from that. When we look at our own Milky Way, we're seeing a galaxy. When we go outside and we look at that big swathe of light in the sky, a swathe as in way, like a pathway that you might walk, milky as in full of light, white, the Milky Way. What you're doing is you're seeing the Milky Way, you're seeing our galaxy from the inside. This is here what our galaxy would look like if we could fly away from it for a few 100,000 years and look back at it and take a photo. This is not our galaxy, but our galaxy looks like this somewhat from the outside. And when you look at it from the inside, it looks like a Milky Way. Now, our Milky Way, and here's an actual map of our Milky Way. This is an actual map. I'm sure the writing's too small for you to read. But we can look at the stars in our Milky Way because they're relatively close, and we can analyze the light and work out what elements are within them, and we can work out the mass of the stars, and from their motion in relation to other stars, we can work out how old the stars are in our Milky Way, and we can see that some of the stars in our Milky Way formed within the first billion years after the Big Bang. Many of the stars in our galaxy are getting towards 13 billion years old, in the region of 12.5 to 12.8 billion years old. So we know that this Milky Way is a very old galaxy. It formed relatively soon, within a billion years after the Big Bang. Now, where are we in this picture here? Well, it's a little bit hard to see, but if you start off in the middle where there's that yellow bar, this is a barred spiral galaxy, and you go down, you can pass through two spiral arms of the Milky Way before you leave at the bottom. In between those two spiral arms, there is a spur, a faint connection connecting those two arms together. This is called the Orion spur. And if I zoom in on the Orion spur, this is actually upside down compared to the last image, but there is in this image a spur, a diagonal spur going between two of those arms, and our sun is about 2/3 of the way to the right of this image and about 2/3 of the way down from this image, in the middle of that spur, the Orion spur. Um, that is where we are in our galaxy. And if we try and figure out, well, that's our galaxy. What about our solar system? What can we learn about our solar system? Well, one interesting thing about the early universe is the early universe was seeded just with the most basic of elements like hydrogen and helium. And so when you look at the composition through spectroscopy of distant stars, um, they tend to have uh, more hydrogen and helium in them. In fact, all earlier stars throughout the universe tend to have more hydrogen, more helium in them than other elements. And it's within that intense pressure and heat of the nuclear reaction that's going on inside a star that these hydrogen and helium atoms, they're forced into each other with such immense pressure that they fuse together. You get nuclear fusion. And when that happens, you get heavier elements. You get elements joining together to form heavier and heavier elements in our periodic table of elements. And so when we look at what our Earth is made of, we know that the Earth is made of, and we are made out of, heavier elements. Elements like carbon, for example. We are carbon-based life forms. We have a lot of carbon within us. We have oxygen within us, H2O, oxygen. There's a lot of heavier elements, not just on this planet, but throughout our solar system. And we have, I don't know, thousands of different ways of aging our solar system, of judging the age of our solar system. And when we judge the age of our solar system, it comes out to be about 4.6 billion years old. So our solar system is 4.6 billion years old in a universe that is about 13.8 billion years old. And because of the composition of our solar system, we can tell a lot about how our solar system must have formed. And this is what we deduce. At some time in our galaxy, there were stars that were burning, and they were fusing all of these lighter elements together over the course of their lifetimes. And stars are born. They fuse all the elements together, and then they eventually run out of steam. And well, it depends how big they are, but somehow either through a collapse and an explosion or just gentle drifting away of the elements around the outside, a lot of those elements that were inside the stars get thrown out into space. And probably about 5 billion years ago, there were stars that were seeding our region of space with elements that were created within other stars. And then about 4.6 billion years ago, they started to come together, coalesce due to gravitational forces, and you started to get not just elements, but little bits of sort of dust, we call it, which coalesced into little stone-like pebbles, which coalesced into boulders and asteroids, and this huge big area of space started to coalesce together. And when things come together, you very often get this spinning effect, like water going down a plug hole. And our solar system started to spin as the energy fell inwards. And this is gravitational potential energy. If you remember your high school science, energy is always conserved. And when something falls in and then stops falling in, that energy has to go somewhere, and it turns into heat. And so in the middle of this swirling vortex of matter and energy, you end up getting very, very hot, big mass that eventually becomes so massive that there's enough gravity, enough force pushing the atoms together that you get nuclear fusion, and you get the sun, Sol, being born. And that happened and 4.6 billion years ago. And at the same time, you've got around the outside, you've got swirling areas of matter which are coming together, also very hot, not hot enough and not massive enough to form a sun, but massive enough to form planets. You know, everything in our solar system almost is swirling in the same direction. If you look down at it from above, like as though you're looking at from the north down, it's swirling in a counterclockwise, anti-clockwise direction. The Earth is, the moon is orbiting around the same way. We're orbiting around the sun in the same way, and all the planets are doing the same thing. So that's how our Earth formed. Now, the Earth, when it formed 4.6 billion years ago, was a hellish place. The history of our Earth can be divided into 4 eons. And the first eon was called the Hadean eon because it was kind of like hell, like Hades is to do with hell. And this is an artist's impression of what Earth must have looked like back then. And that big sphere you're seeing in the distance there, that's actually the moon. The moon started off much closer in at that point in time. And at that time, and for hundreds of millions of years, the Earth was hot. It was molten. It was like lava all around the Earth. And there were still meteorites, asteroids, hailing down all over the planet, adding more heat. The atmosphere was largely carbon dioxide. There was not an oxygen-rich atmosphere here at all. You would not be able you would not be able to breathe if you went back to that time. The temperature at that time was around 230 degrees Celsius. That is about 448 degrees Fahrenheit. Not a nice place to go on vacation. That is what the Earth used to be like. That's how it started. And then natural cooling occurred, radiating heat away off into space. And you start to get the surface rocks solidifying, and you end up getting to the late Hadean eon. I'm not sure how visible that is. Another artist's impression of the Earth and the moon. Still very hot, but with some crust having formed. Then we reach the second of the Earth's eons, the Archean eon. Archean, similar to the word archaic, very, very, very old. So after about 600 million years of cooling, we've got this solid crust, and the Earth has cooled sufficiently that you start to get rain falling on the Earth because you've got lots of water vapor in the atmosphere, and that condenses, it cools enough and condenses sufficiently that it can rain down on the planet. You still had a lot greater pressure there, so that water, you wouldn't want to be standing in that rainwater. It would be hotter than boiling. You would not survive still. But in that eon, the Archean eon, the Earth is starting to look a little bit more like how we see it today. And then you have something very special happening. And the very special thing that happened was that you had very simple life evolving. Now, scientists are learning more and more every year about how when you put a bunch of lifeless molecules together, like what used to exist back then, how under the right conditions, you do start to get organic molecules forming, carbon-based molecules forming that are the constituents of life as we know it today. I know that this is going against some people's beliefs, but if you learn about this subject, if you learn the science of it, you will see that there are certainly holes in that we're trying to piece together the missing pieces in this jigsaw puzzle, but the pieces that are there are very solid. And we have found, for example, fossils that date back to that time. This is a fossil, a photograph of a fossil that's about 3.5 billion years old. It's a fossil of cyanobacteria that formed large mats in shallow oceans, just like in this image here that we looked at. These fossils are dated with scientific means and methodologies that are based in logic, that are factual, and you can believe, if you want to, that this is all nonsense, but you can, if you go away and learn what is needed to understand this, you can prove factually this to be true. We had billions of years ago, about 3.5 billion years ago, we had different simple single-celled organisms such as this, a basic cell, a basic life form, swimming around in there, forming clumps and mats together. And these evolved the ability to photosynthesize. Now, I'm using the word evolve quite a lot, and I know that some people are going to have beliefs that evolution is not true. Let's just address that straight away now, because I'm going to be using evolution quite a lot for the next 10 minutes. If you have a parent that gives birth or produces, let's say, 5 different offspring, we know from experience that there's variation in those offspring. There's genetic variation, which leads to morphological variation. And some of those variations will be conducive to survival, more conducive to survival than others. And so the offspring that have the genes that give them abilities that are more conducive to survival are more likely to survive, more likely to reproduce, more likely to pass on those genes. And so with each subsequent generation, you get a natural strengthening of genes. You get natural variations that, and the ones that are conducive to survival, get propagated onto future generations. Evolution isn't just a theory. Evolution is something that can't not happen. It can't not happen. It has to happen given the circumstances on this planet. Indeed, we see all around us evolution, certainly in viruses, in single-celled life forms. We get new strains of viruses that didn't exist last year. That's evolution. And you have the same evolution going on in all species, but, you know, in species that have shorter reproductive cycles, obviously we don't see evolution happening as quickly, but it's been happening throughout the history of this planet. And when we started to get those photosynthetic organisms being able to take what is around them, which is basically heat or energy, and carbon dioxide from the air, and put it into their bodies to make their bodies out of, then, well, that was exciting, because one waste product from that is that, having taken the carbon from carbon dioxide, they release the oxygen into the atmosphere. And they kept on releasing the oxygen into the atmosphere for billions of years. And at first, that oxygen, it didn't even have a chance to build up in the atmosphere. Oxygen is very reactive. If you're a chemist, you will know oxygen is very reactive. It rusts with stuff. It causes stuff to explode. Any oxygen that was in that atmosphere back then, it would react with whichever rocks, like if there was pure molten iron exposing itself, well, that oxygen just goes and joins in there and you get iron oxide. That happened for billions of years, well into the 3rd eon, which was the Proterozoic eon. And in the Proterozoic eon, you get more advanced life forms evolving. This is what it looked like in that eon. And also in that eon, you get to the stage where there's enough oxygen in the atmosphere that it's reacted with all of the available elements on Earth, and then it starts to build up. You get oxygen building up in the atmosphere. And that oxygen builds up and builds up and builds up and moves us towards where we are today. Um, in the fourth eon, the one that we're in right now, about 541 million years ago, there was something called the Cambrian explosion. There was a big explosion of life, not literally life exploding. You had more and more interesting organisms evolving, and each branch, each line on the tree of life had more and more and more different species evolving, because the more variation you get, the more variation you get. And you had amphibians and fish evolve. I I'm speeding up a little bit because I know that I don't have a huge amount of time left, but I could quite easily talk for many hours about all of this. One significant thing that happened was about 350 million years ago, after billions of years of photosynthetic organisms taking the carbon dioxide out of the air and putting oxygen into the air, you have these big swamps all around the planet that are pulling out the carbon dioxide, taking the carbon dioxide into the bodies of these plants, and then over time, slow processes occur where these plants fall to the ground, they get pushed, they get sediments put on top of them, they get pushed down more and more and more and more, and over the next few million years, they turn into coal. And the Earth was looking very different back then. You had a big continent called Pangaea. And this all continued. And in the oceans, you were getting organisms dying, photosynthetic organisms like phytoplankton dying, taking out from the atmosphere all of the carbon dioxide that was in the air, taking it into their bodies and putting it under the ground in the form of oil, under the oceans in the form of oil. This is a very important thing for people to understand. You've got to really truly understand the science of this before you can understand why burning fossil fuels today is not something we should be doing. Because when we dig up fossil fuels, coal, oil, natural gas, and we burn them, we put back into the atmosphere the carbon dioxide that has taken billions of years to take out of the atmosphere. We are, in just the space of a couple of hundred years, completely reversing this process that I've been talking about for billions of years. And a lot of people don't get what the problem is. The problem is that the Earth's natural atmosphere is not breathable. The Earth's natural atmosphere is carbon dioxide. And by burning fossil fuels, we are changing the atmosphere back millions of years. We've already changed it back millions of years. This is serious. This is a big problem. And back then, the temperature was hotter. Why was it hotter? Well, carbon dioxide acts like a blanket around the planet, keeping the heat in. And we're putting that carbon dioxide back into the atmosphere. We're re-blanketing the Earth. And the temperature is going up and going up and going up. And there's been a steady increase in the temperature for, well, the last 50, 60 years. This is a big problem. The biggest issue facing this planet right now is not taxes, it's not abortion and various things like that. It's not even the wars going on around the world, all of which are big issues. I'm not trying to put those down. But the biggest issue, the issue that we need to put at the top of our list of issues, is us burning fossil fuels. We need to stop now. And we've already committed ourselves chemically into the atmosphere a huge increase in temperature associated with what we've already done. And we are, and I'm saying this with knowledge, not with belief, we are pushing our world towards uninhabitability within our lifetimes, within most of the lifetimes of most of the people watching this show. If you look in the new, well, if you look at proper news, not misinformation networks, but if you look at proper news, you will see that everything I'm talking about is real, is true. We have the data, we have the proof. The temperature keeps going up, keeps getting hotter every year. We're breaking records. This is really, really, really problematic. So I hate I hate mentioning the word politics, but if you want to become a galactically wise person, then whatever political opinions you have, whatever country you're in the world, please look to the policies to do with fossil fuels of the political parties in your country. And please do the right thing for countless billions of life forms, millions of species over the next 50, 100, 10,000 years. The well-being of these beings is dependent on how people vote. And voting for political parties that are pushing to end fossil fuel use is important. Hey.
So Rupert, because you hit something that's very important.
Yeah.
I just put an article in chat. The U.S. solar installations hit quarterly record, making up 75% of new power added. And that number is going to increase. So as far as that energy being a resource, less burning of fossil fuels, more solar production. I am running my house on solar, and I got to tell you, it makes dollars and cents, not just practical sense.
That is fantastic. And Bill, you're an expert in
I love my
climate,
brother.
aren't you?
I studied it when I was younger, so yes. Anyway, great seeing everybody here. Rupert, as always, great show. And you're going to be on with Annie tomorrow, Andrea.
Yeah, in A World Awakening.
Yes. And Patreon?
Oh, yes. Please, if people would like to help me to combat things like climate change, global warming, and moving the world in a better direction, please join my Patreon group. I can see I'm out of time, Bill. So I would like to thank you for popping in, and at the end of this show, it's always a pleasure to have your wisdom in this show. And I'm going to say goodbye to everybody. Peace, love, and happiness to all of you.